Everyone, and welcome to the March 6th Tampa Devs meeting with our wonderful speaker, Ryan Clements. Really glad that everyone can join us. So, give you a quick rundown of the agenda, talk a little about Tampa Devs if it's any of your first time at one of our events, give you an update on events and programs that we have coming, and then hand it right over to Ryan. So first things first, we are Tampa Devs. We are a community of software developers seeking to grow together. Now, what does this mean? We're a registered nonprofit that serves the Tampa Bay developer community, and our goal is to bring people together and give them access to different types of career building opportunities and resources and so on, and really help Tampa Bay grow as an industry leading technology hub. That is our goal, is to help nurture the progress and strength of the technology industry here in Tampa Bay. So let's start by talking a little bit about BayHacks 2024. Now, we had 240 people come to this event, and it was just an absolute blowout. It was wonderful. How many of you guys actually made it out to BayHacks, out of curiosity? We got one person, two people. I'd like to thank Rich right here. He's actually one of the incredible sponsors that we have for BayHacks. His company, Fair Economy, was actually one of the first that came on board to make this event possible. But yeah, it was amazing. We had, again, about 240 people, 19 teams, and we distributed $2,000 in prizes. I got to live my Mr. Beast fantasy for a couple of days, and it was just fantastic. So some upcoming events. On the 27th of March, we've got a networking event happening at Thrive downtown St. Pete. That is not a stock photo. That's a real photo of the last one that we did at Thrive. This is a great event. Thrive's a wonderful venue, and if you're in St. Pete or you're willing to make it across the bay, this is definitely something that's worth checking out. Next, let's give you a quick update on the mentorship program. Now, if you don't know already, we do have a fully online mentorship program. It has 114 people registered and 23 active pairings running right now as we speak. This is a completely free program that we put together to connect folks that are looking for mentors, maybe looking for people to help them along with their career development journey, or someone that's more experienced to bounce ideas off of. And it's a really great resource for the community. So definitely check it out at go.tampa.dev/mentorship or scan this QR code. Some news about Tampa Devs Online. So we do have a Slack. If you're not already in the Slack, you can join us in Slack at go.tampa.dev/Slack. There are 1,407 local developers in this Slack. It is a wonderful resource to stay connected to the community. So definitely check this out. We also have this super cool community page at tampa.dev. This has our group and also a lot of other wonderful local meetup groups that are in the technology space. So it's definitely something that's worth checking out. We also recently launched a new website called Tampa Devs News, and I can actually show you that right over here. This has got basically like a blog roll of lots of local developers who are doing interesting things. But we also have some other categories, so you can come in here and you can see, for example, business news in Tampa Bay. You could look at, say, like things from startup incubators like Embark Collective or Tampa Bay Wave. So this is a wonderful resource that we literally just put together this week, and it's pretty cool. So that's a fun experiment that we're playing around with. Some other things that we've got on the net. Let's talk a bit about Tampa Devs Talent. This is our job board platform that we built. It's a reverse job board. And the idea here is that you can just create a free profile, fill it in with your details, and then we've got businesses that subscribe and that will actually reach out to you if they're interested in hiring you for a position. You can donate to us at tampa.dev/donate if you like the things that we're doing. And you can also connect with us on a myriad number of different social media platforms as well, if you want to rep Tampa Devs and stay up to date with the latest news from us. If you want to speak, you can reach out to us at speakers@tampadevs.com or just go to go.tampa.dev/speak. We'd love to host your talk if there's anything you'd like to share with the community. And with that, I want to hand it over to Ryan, who's going to tell us about tuning app performance on Android for 150 million devices, which is an incredible story of scale. Thank you. Really appreciate you, Ryan. Give him a big hand, folks.
Well, thank you all for coming, and I also want to give a big thank you to Tampa Devs for hosting and in allowing me to share my story. The story opens up in 2022 when I was doing web development. That's actually where my background is. I do a lot of web development work. And I got a LinkedIn DM saying, hey, do you want to learn Android and come work for Amazon? Yeah, I do. So they got me through the pipeline. I did a lot of prep, and eventually I walked through the doors, and I landed on the Fire TV team. So if you're not familiar with Fire TV, how many of you know Roku? Yeah, they're their direct competitor. So if you know Fire Sticks, that's the thing I programmed for. And specifically, it was that app. It was the news app. This app comes pre-installed on every device, every Fire TV stick, every Fire TV that Fire TV makes, which is when I was joining the team was about 150 million. Now it's way more than that. The news app had 50-ish million, 55 million when I was there, daily active users. So it was an app that required a ton of scale. Specifically, the app provided a streaming feature where you can view the news, your local news or national news or global news, and we would make money by inserting ads into the stream at different points. And this was a very stable app. It allowed us to pay our salaries. It was like the flagship product of our specific organization, because this was making a chunk of change, and it was providing users with what they wanted. Like, they loved the product. Now, what we wanted to do with this was we proved out the business model of the news app, that we could deliver streaming, like a streaming app enabled via ads, but yet it was all very expensive to make updates. So the business people said, you know what, let's make an app like the news app that had the same sort of business model, but we genericized it to tons of other content like sports and trailers and food and travel, you name it. The idea was that whenever they wanted new content to be displayed on the app, it would just be a configuration change in the back end rather than an overarching, they call them OTAs at Amazon, where they would do an app update, which would take months of lead time. It would be extremely expensive. A lot of people needed to get involved for even just a small change in the app. So having this configured via the back end would be a great boon to the organization and to users, because it means we could iterate faster. If you're nerdy like me, the specific architecture we went with was called server-driven UI, or SDUI, where the server sends JSON of the UI structure rather than just like your normal DTOs that you might expect. So anything in this screen you see here can be configured just by changing back-end configuration. For us, it was actually just JSON files. The idea was that there would be a CMS built on top of it, but we're scrappy, so we just manually edited it. And it took it to add one row, or add a whole new column, or a whole new category, we call them, it would take a day, as opposed to months of lead time. So this was extremely valuable. And this is where I start to enter the story. We wanted to build this, and they put me on the team, and we started iterating like crazy, trying to get that MVP out so that the product managers could finally use it. And with the challenge ahead, we started iterating. Cue the 80s montage music, where we're coding, and then we're shipping, and we're coding, we're shipping, and shipping to beta devices. But eventually, we started to get reports of slow startup time. Now, this slow startup time was about 40 seconds just to start up the app, which was crazy. Some developers were seeing it, some developers weren't. Yet, this was a massive problem, massive problem. There are some internal applications that could handle 10-second startup. If you're working in some enterprise company, that might be fine for an internal tool. But for an ad-enabled app, this was deadly. We need this under 2 to give you an idea of where we needed to be. So before I get into what we did, because that's where the story picks up with me, I'd like to introduce you to who I am. My name is Ryan Clements. I'm the owner of ByteBot. It's a software agency that helps ship full-stack solutions to their clients through training and consulting. I specialize in pretty much anything TypeScript. If you have full-stack headaches, then I can help you here. And one of the things I do is help back-end developers with the front ends that frustrate them. And I'm comfortable working in, I kind of bring solutions to wherever people are working with. So I've worked with tons of different technologies before. Nothing surprises me anymore at this point. And if you want to get in contact, don't feel like you need a take a picture of this now. I'll put it up in the end. But I also have a newsletter where I send out the blog posts that I write, just sharing my learnings with the world. And connect with me on LinkedIn. I'd be happy to chat. And I also have a Twitter I'm fairly active on. Now, going back into the where I specifically start with these performance problems. Our first findings, now granted we weren't, there's this high view of these FANG companies where, everyone is, PhD in everything. But actually that wasn't the case. Our team didn't have a whole lot of expertise in Android. I mean, we did ship this news app, but we didn't feel like we were really masters of the tech. So when we were tasked with taking the startup time from 40 seconds to 2 seconds, we actually started with just low-hanging fruit, just putting timing statements around the code, figuring out, okay, what's slow here? I mean, the app was simple enough, being a prototype, that we could actually figure out something really quick, which leads to my first lesson, which is control your DSER, or your serialization and deserialization. For anyone not familiar with this, when you make a call over the network, you have to put the objects in some sort of format and send that over the wire, and then the receiving end has to take that from the wire format into objects that you can then manage in your language. Depending on how you do this, this could be extremely detrimental. Because we were using Jackson, and Jackson by default uses something called reflection, which is extremely heavy at runtime, particularly on these teeny tiny little devices that we had to program for. On the server side, reflection can be very useful, especially since your startup times, especially if you're writing a microservice, you can wait a minute or two for your microservice to start up. But for an app, you need this in seconds. So if you're doing anything reflective that has a very high overhead, you really want to avoid it as much as possible. Now, the solution here with Jackson specifically, in case you're curious, is you write classes like these to tell Jackson, okay, I got an item, this is how I serialize, and then there's a deserialize method. And it's actually really simple to plug this in when you create something called an object mapper. But it would be nice not to have to configure this anytime we had a new DTO that we had to put over the wire. But alas, we were scrappy and we wanted to move forward. But we got a 50% performance improvement just by cutting out the reflection in the Jackson library. This brought it down from 40 seconds to about 20 seconds. So, okay, we got this far. We still have a lot to go. What else can we do? And this brings me to my second lesson, which is keep your dependencies up to date. Now, if anyone, do I have any Android programmers in here? You got one? Okay. Well, two-ish. All right, so with Android, there are lots of frameworks out there that let you do deserialization at compile time. Or you can generate a lot of this boilerplate at compile time. But one of the things that we hit very, very quickly was we were using very old dependencies to build our apps, which prevented us from using these new tools, so we're basically stuck with Jackson. But I said that we're building a new app. Why are we worrying about old dependencies? Can't we just start anew? Well, this is where business comes in. Remember how I said we wanted to create a new app? Well, how are we actually going to do that? We said, okay, we can create a separate app per genre, but that'd be extremely expensive. We don't want that. We want a unified experience. That wouldn't be good for the customer. We also could rewrite the existing app in a completely new deployable. This would require duplicating a lot of things that we already set up for the news app. And at the same time, the news app was going to be deprecated since this new Fire Channels app that we were creating was just going to be another category in it. This was going to be the superset of news, if you will. So that didn't really sit well with us because it would lead to a lot of rework. So we had a third option, which was create a new app that had its UI configured from the back end, but we Trojan horse it into the original app. Now, we got sign off on this, and we moved forward because this would allow us to iterate quicker. Now, if you're graph-oriented like I am, this is basically what the app looked like. You had the same APK that we would then ship to users, but we would separate the experiences out. We had the old experience, so this would be the news application proper. And then you had the Fire Channels experience that would kind of sit side by side. The entry point of the application, so if you're unfamiliar with Java, your application class can be like your main entry point. We would figure out how the app was started up, and based off of the configuration in that, they call them intents, we then could figure out, okay, did you want to start at the news app or did you want to start at the Fire Channels app? The old parts are in orange, and then the green parts are the old parts are in orange, the new parts are in green, and then the red parts are the ugly parts are in red. We had a dependency here that we couldn't avoid, but I'm kind of hand waving with how simplistic this is. But the whole point is that this Fire Channels app had to exist in the existing build system. It had to exist within the same frameworks and libraries that we used. We couldn't just bring in anything. And remember, these devices are really small. We can't just add a completely new library because that would bloat the APK size. Now, I don't know how large APKs are for the generic APK for the App Store, but at least for Fire TV devices, 15 megabytes is large. So now we're trying to fit 2 apps into one, and the old app is already pushing like almost 10 megabytes. So what are we going to do? We had to be very, very careful with what we brought in, and at the same time be okay with the dependencies we had. So our poor app was stuck on Kotlin 1.3, which if anyone does Android programming will know is actually kind of old. Then we had to use Android support libraries, which for those of you that don't know, there was a massive shift in the Android ecosystem around 2019, right when our dependencies were basically vacuum sealed. And all the Android support libraries, one of the big problems that they solve is that they smooth over the differences. You bundle them in your app, and they smooth over the differences between the Android versions that you have to deploy to. But we moved all of those into something called Android X, where Android extensions, and we couldn't use that because that would be there was a massive migration involved in that, even if it's just changing names. But that's definitely a lot of work there. So we couldn't upgrade those. And then we're also in Gradle 3, which anyone who knows Gradle is really, really old. And to make it worse, we're on 3.0, which is really, really old. And I mentioned 3.0 because the 3.2 is actually where you want to be. It allows for better IDE integration and a couple other things on top of that. So what does this mean for our app? It means we can't use Flow because in order to use Flow in Android to make it useful, you need mutable state flow, and that's in Kotlin 1.4. You can't use Android X.anything because you're stuck on the support libraries. Just trust me on this, and including Jetpack Compose, which if you're familiar with that or listening online, if you put the 2 and 2 together, you know that servant-driven UI and Compose would work really, really well together with the paradigms that they have. You can think of Jetpack Compose as React, but for Android. But we couldn't use that because you need to be on Android X. We couldn't do that. So anything that needs Android X, so sometimes we couldn't upgrade dependencies because they brought in Android X dependencies, which broke the build, so we couldn't do that. And this also meant that certain versions of Android Studio we couldn't use because Android Gradle plugin, Android Studio, and Gradle used to all be bundled up. They eventually shifted this after like 4.6 or something. I can't remember the exact number. I used to know. But also data binding wasn't that great. And surprisingly enough, I'd like to see more people talk about this. Documentation. When you are on older versions of your stuff, what are you going to do when you need to look up things? These libraries don't always keep around their documentation of these older versions. Some go really far and have documentation for every version they've ever published. But this caused a bunch of developer friction on our team and made things go slower, but that doesn't mean we're stopped. We still had paths forward because, what can we use? Well, we can't use Kotlin X at serialization because that requires a higher Kotlin version. We can't use Moshi, but we can use Jackson. So we chose what we had to go with, and it worked. Granted, we had a couple of workarounds to avoid this bad beast at startup, which is it's going to come back. Don't you worry. Now, once we finally decided, okay, we're just going to use Jackson and then move forward with trying to massage everything else, because we keep in mind our eyes are set on shipping this thing. We really wanted to get this out, especially since we're already late as it was due to other things. It's a good story, by the way. The next thing we found out growing in our skills as Android engineers is to use profiling tooling. This is actually surprisingly powerful, and it carried us basically the rest of the way home. So there are some other points I'd like to mention, but if you're not an Android developer, you'd be amazed at how awesome the Android docs are. And this, like most documentation I've had to read with working in old dependencies was pretty awful experience, but this was actually somewhat decent. it was really straightforward, and it took these high-level concepts and really boiled it down to learners, which is something that I think the Android team deserves more credit for. And there are basically two flavors of performance tooling that we found out. The first of which is the Android Studio built-in profiler. So this is so each row here is a thread. The x-axis is time, and then the y-axis is your call stack. So you can see how long you're spending in each stack of your function. So if you see a really, really thick bar, you probably should look there to figure out what's going on in that function call. And the blues here, if you're wondering, are actually just thread weights. But you can see it if you expand it and look into it. But staring at these all day, you eventually get really good at them, and they help you out a lot. I definitely recommend using the tooling inside Android Studio, and the documentation helps you there. The second part I'd like to mention is that we found out that it was very integrated into our app experience. So it integrated into your source code too. So it had a very app-centric view of performance, as opposed to the other tool, which is a command line tool called systrace, and then it's also paired with Perfetto. This is a more system-level tool. You can find out anything about your app in this tool. It is lovely, but we didn't end up needing it. I wanted to show that we learned a lot, but we actually only ended up needing the Android Studio profiler. But sometimes your performance needs demands a little bit more. Take a look at this if this seems like it might help. But now that we had a grasp, we finally found out that we had, we felt that we were on top of the changes rather than the changes, or rather on top of the problem rather than the problem owning us with this tool, and we finally got introspection into it. We quickly were able to identify, especially considering all the documentation out there in talks people gave about how to manage startup performance, is you'll quickly learn that the startup path is sacred, and sacred is a very key word. The activity, now if you're unfamiliar with Android activities, bear with me, but every page you can consider goes through a life cycle, and when you have to integrate different libraries, the documentation will say, oh, you throw this in the onStart callback, and you throw this one in the onResume callback, and you throw this thing in the onCreate callback. It can be kind of confusing, but it leads to a lot of bloat that ends up creeping up on you over time. And because we never checked startup performance until we were just about ready to go to beta, because we didn't check it up until then, it just kind of accumulated. So the other thing I wanted to point out with understanding the life cycle is that you need to know where to look to identify what the startup path even is. Now, Android applications, this is a very simplified view, but you start at initialize, and then you move up as your activity eventually gets user-focused, and then you move down as it gets destroyed or backgrounded or whatever. Now, the actual life cycle is way more complicated than this, especially when you put in fragments. So and you layer on top of that navigation libraries and a couple other things, especially if they do a lot of compile time magic. So you're gonna need to dive into code that feels unfamiliar and identify what it actually takes to go from your application class getting loaded to your application being ready to use. Now, I do have a couple of posts on my blog about how to dive into unfamiliar code. I do this a lot, especially with my consulting work. I have to go into a lot of ugly code bases, some clean code bases, and there are a lot of techniques out there that can help you. I've wanted to write them down and share with them. I'll put a link to them at the end. But your activity class, or any class that you might be working with, ends up looking something like this. You got a bunch of DI code right at the top, or dependency injection. You got a bunch of initialization for, say, logging. Timber is a common logging library that we used at Amazon. You inflate views, you set broadcast receivers, you start kicking off initial tasks. Think about all the background tasks you might need to fire off at startup. Our application classes were looking a lot like this. We just kind of threw stuff in because we needed it to work, and we weren't checking up to this point about how fast the startup was. And then we go on and on and on with this. And the other thing that we found out in our research, now this wasn't applicable to us, but I did want to mention it for anyone looking at this YouTube video and trying to figure out how to make their app faster. You might want to look at content providers. These are configured in your Android manifest XML, so it's not necessarily in what you normally would consider the startup path, but these could sneakily start up code that you might not otherwise think to look at. For example, I pick on Android X Startup, the library there, because they have a really good example, but content providers are started up before all your other code, based off of some documentation I was reading. And this is the feature that the startup library, which is a library that helps you figure out all the tasks you need to do at startup, they have a content provider that does a bunch of work. And like I said, I'm picking on them, but their code is pretty fast. But if you have a bunch of content providers that are doing things on create, especially if they have lines that are kind of scary like this, get instance, discover, initialize, that sounds like it's doing a lot of work. You might want to check out what your content providers are doing, since it's kind of like we found it to be like a silent way that you could increase startup time. But like I said, we checked for this, we didn't see anything here, so we had to move on. But what we realized with considering your startup path sacred, okay, you might know where all the lifecycle methods are, but what is considered started up? This is not a technical term, this is a business term. You need to define this with your users, with your product managers, because this is a user-centric term. For us, this meant we needed to load up the first frame of the video when we're playing the video, and then we need to aggressively defer everything else. Because if we can't capture the user's interest, especially with an app that's ad enabled, we need to, if we can't capture the user's interest, that's lost money. And that also isn't a great user experience, because they're having to sit there and wait. And remember, milliseconds on developer machines translate to like seconds on actual devices, because the actual devices are really teeny tiny, especially if they're old. So let's go to our playback page. This is one of the pages that we had in the app. It was responsible for, shockingly, playback. The playback page, in order to load this, it needed to go through a couple of different steps. We needed to instantiate the application class. We needed to parse the intent to figure out which experience we're going to. We needed to start the relevant activity. We needed to instantiate the minimal amount of dependencies. Then we needed to fetch the initial data. Remember, the server needs to have a say in what to actually draw on the UI. This is cached, of course. We need to determine the page to load based off of that server response. We need to inflate the view and place the fragment. We need to load the video player and then finally play the video. This is where we want to get. We got all these steps. But we couldn't figure out what to look at until we went to the business and said, what does it mean to be fully loaded? This is why it's this important. This is why this is extremely important, since it tells you what you need to look at and what you need to not look at. Since we knew the exact steps we needed to get from our application to start it to playing the video, namely the first frame, we were able to take this list and then compare it to what we were actually doing, which was instantiate the news application, instantiate a dependency graph, literally everything, including the news app. It was a mess. It turns out we were instantiating tons of heavy classes that were impeding our ability to get to the first frame. Then we start a background task for a lot of stuff. Then we parse the intents like before, we start the activity, then we do more instantiation, because why not? And then we fetch the initial data, and then for some reason we did cache maintenance that was blocking. And then only then we determine the page to load, we place the fragment, we load the video player, and then we play the video. So notice all the red here. This is what we not want to do. You couldn't have this unless you had the definition of what is considered actually fully loaded. Now since we had this, now we have a framework to determine what we need to defer. So given the steps that were ahead of us, we identified the first area of optimization. So we were done with the low-hanging fruit. We're again at the about 20-second mark. We needed to get that down to, again, around the 2 seconds. The next biggest thing that we could do was optimize dependency injection. Now, we were using Dagger 2. Dagger 2 is a common framework for dependency injection on a bunch of Android devices. We were using a slightly older version. I was actually pretty happy with the version that we're on, all things considered. The newer Android tool to use is something called Hilt. There are some other tools called like Coin, K-O-I-N. That's multi-platform, I believe. But this is what we were using. This is a compile time framework, so it doesn't use any reflection. Like if you write any Java backend, you probably use something like Juice. That's reflective. Couldn't use Juice. But Dagger was created as a response to the need for DI that wasn't reflective. And the great thing about Dagger is that it makes things very easy, but the downside is that it makes things extremely easy. And you can quote me on that because I went through a lot of pain trying to figure out why things were taking so long to inject. And can anyone, so we got the one Android engineer. Can you tell me what's wrong with this?
I don't use shared preferences anymore.
Yeah, so there's that, but assuming you had to use shared preferences.
Well, I'm doing something with JSON and stuff there.
Yeah, there's something dangerous here. And to be clear, so yeah, you're right on it. The danger, to go into a little bit more context, this is something that wrapped a preferences manager called shared preferences. It's an API on Android that lets you store key value pairs. It's extremely fast, but if you are storing a megabyte worth of information like we were, it's extremely slow. And worse, this was in the constructor. So when anyone needed preferences, it injected shared preferences manager. When anyone injected shared preferences manager, you immediately ran into a ton of startup problems because it needed to parse a megabyte's worth of information, which on these tiny devices is very slow. So another example is in this auth manager class we had, the constructor was kicking off a bunch of background work. And again, this is a hunch because we didn't have precise data to prove this, but we had enough data to strongly suggest this. But even though we're starting off work on background threads, the work still needs a CPU to work on, and especially on our lower end devices, there aren't a whole lot of threads to go around. So the theory here was that there was thread contention and context switching that was caused by scheduling or throwing off or starting a bunch of jobs that was slowing down startup because, well, the main work needed to eventually grab a thread. So the solution here was to, we could have just fixed the code, but this is news code. This is from the old application. And we didn't want to regression test the entire news application. Remember, that's our cash cow, and that's the app users really, really love. So we really did not want to touch that if all possible. So the solution here was actually to try to take these out of the dependency graph if possible. Make sure that we don't instantiate it, and then therefore we keep the news application as the same as possible, and then we can just worry about instantiating pure Fire Channels dependencies. And there's a couple other things to say about improving Dagger speed that weren't directly applicable to us, but I thought were pretty interesting, so I wanted to share them. There's this talk that was done a while ago. This is more so of a problem in earlier Dagger versions, but if you're on those Dagger versions, you might want to pay attention. They realized that with all the compile time generation that Dagger had, it was creating a lot of classes, which is putting pressure on the VM during class loading. It's something that you don't really think about. The first initialization was 200 milliseconds, the one that needed to load up all the classes, and then the second initialization for the same graph was 2 milliseconds. So it was pretty interesting that something like class loading could have an issue. They eventually alleviated this in later dependencies, but I did want to point it out that this might be a problem. This might have contributed to the startup times that we were experiencing with having to instantiate so many different classes and load up all the intermediate objects the intermediate classes that Dagger generates.
Did you use a lot of providers?
We did.
Is that part of the problem?
Yeah, so that's another thing that he goes into in his talk is providers and lazy. Using them overzealously can get you into trouble. Now, we actually did find performance improvements using lazy in some places. There were some places that did take a while to instantiate. I believe this was our operational metrics class that we just published stuff into the background. We were able to get some speed up by making that lazy and then deferring that to when it was actually being published.
Yeah, in some more recent Dagger versions, they introduced some improvements, especially for Android, for like the provider stuff. I mean, you're probably aware of that.
Yeah,
I don't know if you tried that out. If that.
Yeah, we're on the later versions. So this talk was done in 2017 to 2017,
Yeah.
and we were using a version that was I think 2019. So I want to say that it was fixed, but we kept this in our back of our mind to think, okay, maybe this is something that could really help us out. It certainly helped out with all the classes we need to generate on the news side. Yeah.
But by the way, can I ask you one?
Yeah, you can ask a question.
You were showing the shared preferences manager, and I mean, what I remember about it, I mean, like the thing that really got me, it was really hard. I mean, I don't use it anymore,
Yeah.
and I'm so glad, but I couldn't really move the initialization of the main thread. When
Yeah.
I was thinking about it, I was thinking maybe if I really dug into the code, I might be able to find a way, but it was just, I mean, without doing that didn't seem possible. I remember I looked at it a little bit, and well, it was a lot of code there, and I'm like, probably not.
Yeah, you're right. So since he didn't have a mic, he was pointing out that he noticed that you can't use shared preferences off of the main thread. And you're right, you can't. What we found, so we considered that, trying to move it off of the main thread, just like queuing something like in a coroutine or whatever. But what we found out is that if you keep the key value lookup, like if the value is really small, it's like under a millisecond sometimes. So that's what we found to be like the sweet spot for preferences. It was when we had to parse a megabyte and then deserialize it into a preferences object. Because this was our database basically. We had some stuff in Room in SQLite, but that's at least where we found the trade-off to be.
Yeah. I mean, in your case, I mean, you might have been capable of simply ignoring preferences and shared preferences and just doing your own thing instead of.
Yeah, we could make that refactored. Alas, this was news code, and we didn't want to. We really didn't want to risk a regression there. But yeah, if we could go back and tell the developers working on this class, like, hey, we're here from the future, we'd probably say don't put everything in the shared preferences. There are other purpose-specific tools. But yeah, thank you for the.
What's the more recent replacement for shared preferences?
Yeah, I forget the funny things that I know a lot about.
I mean, I looked at that and
Yeah.
I'm like, yeah, okay, this is all pretty easy, and I should have just done this myself right from the start. I mean, why deal with shared preferences?
Yeah, and the cool thing about Android is everything's open source. So one of the techniques we used in this application was, we realized that we can program as if we were in 2019, knowing what the future is going to be like. So when we were trying to build APIs in our code and good levels of abstraction, we model it after what we knew the future was going to look like. Because we look at the Android X code and said, we need to refactor towards that eventually. So we actually stole some of that code so that migration in the future would be extremely easy. We actually copy and pasted some of the libraries in some places here and there, especially when it came to developer experience. But yeah, that's a good point. So doing all this, taking control of our dependency injection got us another 50% on top of that. So we're finally within the 10-second range, which is a massive speed up, which leads us to the next lesson that I want to impart is the idea of continuously testing. So we have this idea as software engineers that whenever we have a business requirement, we want to write a unit test for it. This makes sure that if in case anyone adds code that breaks it, we'll catch it early. This, I argue, should be the same for performance, especially when it comes to Android development. If you have a requirement that says we need to start up within X amount of time, you should write a test for it. And you'd be surprised at how many tools there are out there, even in the Android ecosystem. Now, like I said, we're kind of stuck in the 2019 world, and we had our own thing within our team. We had a QA department that was in India, and our process was we would cut an APK, we'd build it off of the main branch of that day. We'd put it on a wiki page. The India team would download it, test it on a bunch of devices, write up their report, and then we would read it the following morning. That was our pipeline, basically. And it worked. They were able to test in kind of like a real user environment, real devices, real network connections. And we made sure it was production versions of the application. So the quality of feedback we got was immense, and that worked for us. We didn't need to refactor the app to use the newer tools that I'm gonna mention. If I could go back though, the one thing I would change is going back to product more about what it means to start up quickly, because they said, kind of make the app fast, and I'm like, okay, I'm just gonna go optimize and optimize and optimize. But without a clear bar, it's hard to report how close you are. And you don't have, the product managers don't have the ability to make trade-off decisions because they don't know how close they are to meeting their performance goals. So that's one thing that I would recommend setting is like, what is the bar? And our bar was, funny enough, YouTube. That was the quality bar that we were getting. So we measured how fast YouTube started up, and we used those numbers and test for those, how close we were to those numbers. So that would be the only other thing. And also making sure that your developers can reproduce what the QA team can do. We had some disconnect that they were using different tools than we were. They had Python scripts that would run the app, exercise it, and record the logs and figure out how long it took to start up based off of that. Making sure that your developers can run it is essential because they're going to come up with problems, and you need to reproduce it, and you can't always reproduce it on using your own tools on a developer build. So not getting that set up was another thing that I would change. I'd do that earlier. But alas, I do want to mention a couple of libraries that are out there. There's this one called Macro Benchmark it's really slick. It's part of the Android X ecosystem, so that's why we can't use it. But if we could, I definitely would take advantage of this because it basically does what the QA team would do in Kotlin as an instrumentation test. And the other cool part about this is if you know something called baseline profiles, I'm about to nerd out, so nerd alert here. The VM that runs on your machine, on the phone or device or whatever that you have Android installed on, it will watch your program while it's running and then do something called just-in-time compilation. But I ask for pardon if I get a detail wrong here. But it profiles your app and then does just-in-time compilation. But that happens on the fly. The first installs of your app aren't going to be that, like the first startup performance for the startup performance for the first couple starts after install aren't going to be that great. So the Google team came up with a really ingenious idea where you would run tests like this. It would create the profile that you would ship with your APK, and then the application your phone or device would use that to figure out, I'm just going to optimize this before startup so that startup happens at super quick all the time. So it's called baseline profiles. We weren't able to use it because it requires using this library, but it's definitely something to look up. And the journey that the Android team took to get there was actually really, really cool. There's another library. The other thing you get out of this is it's integrated into your IDE. So we could see within our own developer tooling that's app focused. Remember the flame graphs? You get those too with Macro Benchmark. So it's a really slick library. Definitely recommend it. And the other unit test version of this is called Micro Benchmark. It's also something cool to take a look at if you have small benchmarking needs. The next lesson I have that we found out was, we made lots of different improvements with figuring out serialization and dependency injection. Well, now we're in the small stuff. We were trying to figure out, how do we get these last couple seconds? Well, this was a really interesting observation that came to me was, remember that big list of steps? Well, they don't all need to happen serially. We need to take the fetch, the server fetch, which is the longest part of that whole startup. It sometimes took a second or two. And we just need to kick that off as early as possible. So the change, this is a real PR. That I'm kind of doing pseudocode here. But I took the fetch initial data and then put it before the layout inflation. It was a one-line change. But now we kick off the call to the server, or if it's cached, then call to the cache. We do it just one line earlier, which now means that we don't need to wait for layout inflation to happen, which also means if layout inflation is always faster than fetching data from the backend, we don't need to optimize it. And we can optimize it for different reasons, but if it's always strictly less than fetching data from the backend, then that's less work on us. So we were able to get another, 200 milliseconds or something, just from this change alone. And then, as I keep on mentioning, that the server fetch was cached. One thing you want to look at is making sure you utilize caches properly. Now, the server was generating a lot of JSON. That was expensive to send over the wire, and network calls are always expensive, so caching it on device was a key strategy for us, within our application. We found a bug looking into this, like we were looking into it to make sure that we were making the minimal amount of calls as possible on any given startup. And we actually found out that there was a bug in our backend that was setting the time to live value at 0. So when it would enter the cache, it would be immediately evicted, which means that another call to the backend had to be made. So that was a fun fix to make. It was another one-line change that ended up having another, like, these calls take like a second or so, so we saved like another second there. So it was this call specifically where we needed to fetch the initial data. And then now we're at the point where we finally get really, really close to our bar. And on some devices, we're making it. We were at 2 seconds or faster. And for the slower devices, the bar was actually more like 10-ish. So we were there, especially now with some of the really old devices, we were having trouble meeting that bar. But now that we had an objective number that we needed to meet and we were reporting on it by now, the PMs do what PMs do best, which is make trade-off decisions. They said, you know what, it's time to ship. And this leads to the next lesson. Only improve what you need to. Now that we improved the startup time from like 40 seconds down to like, around 2-ish seconds for those faster devices, you got to make a call. Is it more important to ship to your users or to get like an extra 100 milliseconds? It might make sense for your app, it might not. For us, it was the right decision to finally ship. So we didn't need to improve anything else in our app, any other lines of code. We said it's time to ship, which now leads to this. If it is very important that your app starts up in a certain amount of time, you need to know what your users are seeing. Nothing simulates production like production. I will die on this hill. Nothing ever simulates production like production. The value that testing gives you is always relative to the fidelity it simulates production. I will talk about this for hours. But anyway, we made darn sure to instrument all of the startup metrics that we'd ever need to diagnose production problems. So we instrumented the time it took to get to first frame for that like the player page, and for our other pages, we made sure to instrument observability on their definitions for what it meant to start up. We also added metadata, like if this was a cold or warm start. Warm starts are when your app's already in the background. Cold is when the OS needs to create it from scratch. So that was another key metric. We also instrumented cache hits, because that was a very important metric in determining startup time. We also recorded the device. We recorded everything around this because it was very key that this was as fast as possible, it was absolutely the right decision to spend extra time doing this, especially when you have 150 million devices that you need to worry about. You can't wait on your users to report this in. You need to know before you ship. And luckily at Amazon, we had platforms that we could use to instrument this. Now, I talk more about on my blog on why production is the only thing that's ever simulates production, and all value is relative to production. But the links to the blog post will be in the end. So we finally shipped. We made it. We crossed the finish line, and our app is finally on the App Store. Well, it's bundled into the device already, but that's just neither here nor there. And it was time to party. Now, looking back at it, it was a long road, and we learned a lot there. And that was only the first iteration. We learned a lot since then and built on top of it with some other improvements. And so I want to share those with you in the form of bonus lessons. So this was a really, really quick win. It was actually enabling compression. One of the other engineers on the team, his name was Oliver, he was playing around with the app. He's like, something feels weird. I think this should be faster. And everyone else was like, yeah, I don't know how it could be faster. And he's like, you know what, let me try enabling compression. So this is where you take your whatever resource and then you use a bunch of math to shrink down its size and then send that over the wire instead. And then on the other side, you uncompress it and then you can work with it. Well, with our backend framework, now is an internal framework called Coral. All you had to do was send this header, which other frameworks, I'm pretty sure, would implement this. But if you send this header from your client, it'll automatically gzip the responses, and this gained like another second. just a simple one-line change. I remember that PR. It was actually really, really cool just seeing that. The second bonus lesson is one that really hits you only at the second release, and it's planned for model evolution. When we were planning our second release, where we're adding a couple other features to the application, and one of the way we decided to release these features was first we're going to release the back end. We don't want to release the app first. We just want to do this phase. So we're going to release the back end. It's backwards compatible with the app that's already in the wild, so that when we finally release the app, the expensive release, we're only changing one thing. So that was the key deal. But one thing we didn't plan for was that the old app didn't have the new UI JSON models. We had a new model type. I'm just kind of pseudocoding here. But we had a new model type called like navigation menu item that the old app didn't know what to make of. So what happened with Jackson? I told you that this head would rear its ugly, this thing would rear its ugly head again, and yet it did. So the solution here was to create like a default class that it would deserialize into, so that the older app would always be able to handle the data type regardless of whether it knew it or not. So this allowed us to evolve the model that we saw fit in the. The other thing that I would change if I could go back is actually add a canary to like every response that gets returned to pre-production and production. Like every response you get from the back end has like a type field of like the type field would just be a GUID. It'd just be a random GUID. Like the app, there would always be something in there that the app couldn't understand. So this would always exercise that code path to make sure that you're being cognizant of model evolution. But this was a latency regression of 25%, which was not fun to deal with. Now, granted, we were so close to releasing, the solution there was just to make the fix and then release the new app version. The third bonus lesson is actually consider removing network calls entirely. This was something that was being considered right before I left Amazon. It was Mike, he was another engineer on the team, was really considering this. And the idea here is, the network call is the most expensive part of our startup. Why not remove it entirely? What would it take to do that? And the idea here was to use a background job to pull data from the server asynchronously, so that you would always have a cache hit when you're starting up. But when you have 150 million devices hitting your servers at an interval of like an hour or so, or however long you tune the cache for, it could create a storm of requests per second, or we call them TPS. So you need to be careful. We had a previous job like this in our news app side that accounted for 97% of all requests that was coming to our system. It was just pulling down some simple configuration. So we moved it to like a static file on S3, and it drastically reduced our cloud bill, which is a really amazing win. So you have to be careful with load. Now that might not be a problem with your app, but it's just something to consider, that you might have scalability problems there. And looking back at all of this, especially after the second release, there was a couple things that really stood out to me. The first is that performance isn't scary. Like, we were a scrappy team. We didn't have PhDs in Android. We were learning on the fly. We were experimenting and testing. One of the things I said is you don't need the fanciest tools. We just used what was out there, what was available to us. Earlier in the talk, I mentioned that we didn't have access to the newest Android Studio, but we used what we had, and there was a lot of low-hanging fruit that we were able to get off of that, to pick from that. You also don't need to be perfect to ship. Iterate. It's one of the secrets to being a really good engineer, I believe, is to continuously get better. We didn't go from 40 seconds down to 2 seconds in one fell swoop. It took months of continued effort and a lot of different perspectives. The other thing is to experiment. Now, one of the interesting parts about our industry is everything is changing all of the time. All of the time. Imagine trying to build a bridge where the theory is changing out from under you every 5 years. That's what it feels like. So whatever works for one person, you have to try it to see if it works for you. I try to throw in a bunch of other things that ended up not working for us, because I know it's going to work for someone else. And the other thing is you also want to continuously test. If this is actually important to your users, then you want to continuously test it. The other thing is I hope you got some transferable knowledge. This was kind of heavy on the Android side, but the fundamental concepts apply to anything. If you need to fix performance problems, you need to define your A, you need to define your B, and then you need to figure out what's in between. The steps to get from A to B are then pretty easy to figure out, and as long as you have the right tooling, which every major framework should come with one, you are well on your way to get at least 80% of the way there, which is what the mark that we decided was shippable. So if you enjoyed this, I'd love to chat. Like I said, I am a software engineer that does consulting work in the web development space with React and Vue ecosystem. I also publish a newsletter. You can connect with me on LinkedIn. I'm pretty active on Twitter. And just to give you an idea of like the fact that I love the web development space, the presentation that you were looking at was actually a web project written in one of the frameworks that I consult with. I don't know why it exited. My computer's acting pretty funky.
So it wasn't just Markdown?
It was Markdown, but it's built on top of Nuxt, if you're familiar with that.
Okay.
Yeah, so if you go into my slides, which are on my LinkedIn, you'll see that I actually use Vue to build them out. And I don't want to take credit for all this. This was a framework created from a prolific author called, his name is Anthony Fu on there. I love his stuff, and I said, I got to use the framework for building slides. Anyway, I just wanted to put that out there. I love his stuff, and thank you for having me. I really enjoyed being here. Yeah.
How long did it take you to optimize it, to go from 40 seconds to 2 seconds? Was it like a sprint?
So no, it was not a sprint, man. I wish it was a sprint. So we got to the point of being ready to optimize around the turn of the new year. So this was like January 2023. We shipped, I want to say it was April-ish, March or April timeframe. So a couple months easy is what we spent.
When it came to the benchmarks that they were giving you from YouTube, you said you didn't reach that on older devices. Did they give you like a range, like, well, on devices this old, we want this startup, or how did they handle that? Because you have people running like the original Android still, because it's just kind of the nature of Android.
Yeah, so that was a good question. Like, how do we define the bar for different devices, right? The way we did it was we profiled YouTube on every device,
Okay.
right? And we took its time to start up for cold starts and warm starts, and then we used those as the bar. And the older now, as the devices organization has like this philosophy that we don't want to make money when users buy our devices. We want to make money when people use our devices. So we will keep supporting these things until they make like 0 cents to support. But that also means we aren't going to support everything. So we have dropped support for extremely old devices. So we didn't have to support those. The oldest one that we had to support, I don't know if I'm legally allowed to say its code name, but it was many, many years old, like 2014 or something like that. It was API level 21. So Android 21 is the oldest that we had to support. But yeah, we profiled YouTube, and that became our bar. And when it came to the end, there were some of the older devices that had we had a very hard problem with that one device getting the performance just right. But it was close enough that we wanted to ship, and eventually, we're getting close to dropping support for that anyway. So that factored into the decision.
Cool.
Mm-hmm. Yeah.
So, what was the mechanism that you used to mitigate the number of network calls? You said you were using S3, or what was
a cache?
Yeah, you're just using on-device.
On-device cache. It was literally just a SQLite database.
Oh, okay.
Mm-hmm.
I was like, when I heard S3, I was like, is that another network service?
No,
Okay.
we used S3 for the new that job we had running in the background on the news side.
Okay.
It was hitting one of our microservices like every, I think it was 6 hours, but for 150 million devices, that was just a ridiculous amount of traffic. So what we did was we we had the same job, but instead of going to the microservice, it would be pointed to an S3 file, like an S3 bucket, and pull down a file from that, and that's how it would get its configuration. We slapped CloudFront in front of it, and then we were able to drop our costs to like probably like $100 or so. It was really, really cheap to do that. And the way we would keep that configuration file up to date is like every 15 minutes, we would run a Lambda that would just go fetch the data from the microservice and then put it in the S3 file. Like that was the architecture there.
Gotcha.
Were the clients actually downloading the entire config file every time, or were they just checking the tag or last modified before downloading it?
They would download it every time. For the old job that we optimized away.
Okay.
That's a question. So are you talking about the old job that we optimized away?
Yeah.
Yeah, we would. It was cheap enough we didn't need to optimize any further after that. Like the main point was we have a lot of traffic on our services with this one endpoint being hit that was just a basic configuration that needed to be updated every 15 minutes. And that was one of the other problems with considering the background job for our Fire Channels app was actually a business requirement. The rows that you see on the app need to be taken down within 15 minutes if the need arises, because sometimes you run into content problems where you immediately need to take it down. So we couldn't funge the TTL. I don't know if anyone was thinking that, but we couldn't do that because the 15-minute was a hard business requirement. So, and the other thing was, unfortunately, with the type of app that we had, we were only seeing a hit rate of like 15%-ish on a good day, because people would load up our app when they were watching news in the morning, and then they would close it down, and then 15 minutes, way more than 50 minutes would pass. So our cache wasn't hit as often as we would like. Yeah.
Can we go a little bit more into detail in what you were encountering with Jackson with reflection there?
Yeah.
You were saying you were able to offload a lot of the disadvantages of reflection specifically by using some sort of lazy loading mechanism or something like that, or?
No, it was so Jackson by default, at least in our version, would look at the string you're trying to, or the byte array that you're trying to deserialize into whatever class, or look at that class.
Yeah.
And say, this type object here, you know what? I'm going to reflect over all of the files to try to load this class dynamically, and that's what it would do by default. But if you could tell it, hey, you should look in this list of pre-configured deserializers that tell you what class something is, and it tells you how to deserialize it for you, that is what we plugged into Jackson to take it off the reflective path.
Okay, maybe if I understand correctly, then you're just doing like this too deep of a recursion into like the classes to do this.
It's more like so you're asking about what is slow about the
yeah. What was really like slowing you down on that?
So it's fundamentally the reflection. So if you look at a JSON file, you have from Jackson's perspective, it's like, oh, I see JSON tokens. It knows how to parse JSON. And then it needs to figure, how do I take these field values and then apply them to some object? Well, it doesn't know, by default, it doesn't know your object shape. It doesn't know your object shape. So it has to look at the object shape and use reflection to figure out, oh, you've got these 5 fields and they're of this type. And then some of these fields have these fields on them, and then I need to map them over here. That process is very slow.
I think concretely it might be the class.forName call. Was that the class?
I don't know specifically.
Because I know that one is like very slow, or used to be very slow.
I don't know exactly what
And there's other reflection
call,
stuff
but
as
it's
well.
something. It was always the reflect. So the way I found this out was I would be profiling using the profiler, the Android Studio profiler, and it would always slow down when it was trying to use reflective-based APIs. It was like java.reflect or something like that. So it's had it in its package name. I forget exactly what APIs it was, but you could kind of poke through the code base and see, oh crap, it's always slowing down when it hits this particular line within Jackson, and it was the reflective parts. Any other questions? Thank you for that. Oh, well, thank you for your time. I enjoyed being here. And thank you to Tampa Devs for hosting.
Thanks for making it up.